Good morning. Thank you for joining this session. I'm ICOA2025 and I'm pleased to present my paper titled Smart University Ontology for Educational Data Mining. As educational technologies grow, the amount of data generated by students, teachers, and systems becomes enormous. The real challenge is not just storing this data, but making sense of it. Educational data mining helps us uncover patterns, but to ensure that insights are accurate, consistent, and shareable across systems, we need a semantic representation that add structure and meaning in the raw data. In this work, we present a briefing of educational data mining methodology in education. We've also talked about how to incorporate semantic educational data in the ADM process for meaningful processing. To complete the job, we develop Smart University Ontology as a paradigm for managing the diversity of education data to provide a knowledge database able of enhancing the ADM results. ADM is about going beyond simply gathering information. Is about finding patterns that help us understand how students learn and how we can support them better. For example, by predicting dropout risk, we can intervene early. By classifying learner, we can guide them toward the right courses. And through personalization, we can create adaptive learning environment that fits each student's needs and also helping administrator make informed data-driven decision. This definition indicates a broader view of the domains involved in educational data mining. EDM can be conceptualized around three main areas: computer science, education, and statistics. The overlap between these three areas leads the additional related field closely related to EDM, such as computer-aided education, data mining, machine learning, and learning analytics. Education data mining is the process of converting large volume of educational data into meaningful insights that enhance understanding of student behavior and learning conditions. These insights support the improvement of teaching strategies, learning experiences, and data-driven decision-making within the educational systems. Typical parts of the EDM process include data acquisition, pre-processing, data mining, and validation of results. The educational data mining process derives meaningful insights from the raw data produced by the educational systems. ADM may involve the collection and analysis of diverse data types, including qualitative and quantitative data, personal, administrative, academic data, social interaction, visual and facial expression. Recently, research has focused less on collecting data and more on organizing and analyzing existing data to perform semantic analysis that support interdisciplinary learning data through data interoperability. This benefit highlights why semantics are so important in educational data mining. By structuring knowledge, we make it reusable across different systems. Semantic interoperability ensures that systems can communicate and understand each other, while machine-readable representation allow computer to process and reason about educational data automatically. Together, these benefits make educational analytics more powerful and sustainable. clarifying the fundamental difference between ontology and taxonomy enhance understanding, referring to ontology as one with a subclass-based taxonomy hierarchy, provide greater precision and reduce ambiguity compared to using the term ontology alone. Figure 3 illustrates the relationship between an ontology, taxonomy, and the dataset. An ontology is outcome of extensive interconnected knowledge processing within an organization. Accordingly, the ontology development process can be outlined through the following steps: knowledge acquisition, modeling, representation, evaluation, and reuse. The goal of our paper is to draw the Smile University ontology in order to present interdisciplinary knowledge and learner profile and support collaborative learning and semantic data mining. The main component of our ontology is the learning objects ontology, user modeling ontology, and learning design ontology. As shown in the figure, we follow a step-by-step process to implement the Smile University ontology. This approach ensures that all components, students, courses, faculties, and resources are properly integrated. By following these steps, we can build a structured, interoperable system that supports analytics, personalized learning, and data-driven decision-making across the university. Finally, we evaluate the homogeneity of the Smart University ontology using the regional pilot. Figure 5 represents the result of the reasoning. The ontology is now ready for incorporation into a data mining process that will enable pertinent or relevant research due to semantic representation of the student profile and a more detailed description in the field. Previous studies have demonstrated the effectiveness of educational data mining and decision making and predictive modeling by acquiring and processing data tailored to specific challenges. Our research extends this approach by integrating a semantic layer through the development of Smart University ontology. This ontology enriches student profile used and collaborative projects, broadening the range of representation skills and promoting interdisciplinary teamwork. As future work, we aim to extend the interoperability across different systems and develop an advanced recommendation model toward fully adaptive Smart University. And thank you for your attention.